previous videos, we are going to see about the analytical techniques. We are going to see about the ultraviolet visible spectroscopy, atomic absorption spectroscopy. Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. Today in this video, we are going to see about ultraviolet visible spectroscopy instrumentation. In the previous video, we have seen about the principle that is involved in the ultraviolet visible spectroscopy. Okay, now let's go to the instrumentation part. You have the source, that is either the hydrogen lamp or the tungsten lamp. So this hydrogen lamp or deuterium lamp, it is for the source of ultraviolet rays, and tungsten lamp, it is for the source for visible rays. So you should have a range of wavelengths from 200 nanometer to 800 nanometer in the UV visible spectroscope. Okay, next this is the source, and next is the, from the source you have the entrance slit. Okay, through the entrance slit there is a monochromator over here. So what's the purpose of the monochromator? The monochromator will select only a range of wavelength that has to be sent. Okay, so the range is from 200 to 400, 400 to 800 nanometer range. So you can use either the gratings or the prism for selecting the wavelength range. So this is the role of the monochromator. Then it will absorb all the wavelength and it will only emit a particular range of wavelength through the exit slit. Okay, then comes the exit slit. There you have a beam splitter. So what's the role of the beam splitter? You will have a particular intensity of light that is coming out through the exit slit through the monochromator. Okay, so the beam splitter, it splits the intensity of the light that is coming out of the exit slit equally into two. So one intensity, it is sent to a blank. Okay, this is called the blank or reference cell. And another intensity of light, it is sent through the sample. So what is this blank or reference? So it contains the solvent that is used to make the sample. Okay, and this is the sample, and these cells should be equal. That is the cuvette that is used for the blank and the reference should be a pair of cuvette. So if suppose one is broken, you should not use the some other pair. You have to use the same pair only, because according to the Lambert's law, the intensity of light that is coming out, it is proportional to the length. So we should be very careful while choosing your cuvette. Okay, so this, after passing through this cell, what will happen? The intensity of light that is passing through the blank, there is no absorbance over there because it's a blank solution and you get I naught. And in the reference, when the intensity of light is passed through the sample, the intensity of light that is coming out is I. Okay, so this is come out, and here is the recorder. So recorder, it gives, like you have it gives you the intensity of light, that is the observance value. If the intensity of light is very high, which is coming out, you have a high peak, and if it is very low, you have a low peak, and if there is no observance, then you don't have any peaks over there. Okay, so now is the detector. Detector that is used as a photocell or a photodiode is used as a detector. Okay, so photo means it will detect the light, right? So here, this detector, what's the role of the detector is, it will compare the intensity of the light that is coming out of the sample and the reference, and it will convert into electric current. So your display or the recorder, it gives you the display according to the intensity, difference in intensity of light that is coming out of the sample or reference. Okay, so here in this sample and the reference, you have the, if suppose the observance, here you have the intensity I naught and I naught that is coming out. There is no difference in the intensity of light. If suppose the sample does not observe any wavelength, any intensity of light, then A is into log of I naught by I. So I naught will be equal to I and the observance will be equal to 0. If suppose in this case you have I over here. Okay, so I naught is greater than I. So in that case you have the observance value is greater than 0. Okay, so this is about the complete instrumentation of ultraviolet visible spectroscopy. Applications of ultraviolet visible spectroscopy. Now we'll see what are the different applications. You can determine the functional group of the any compound. Then extent of conjugation in polyenes can be determined. Then identification of unknown compound. Okay, that can be determined using the ultraviolet visible spectroscopy and elucidate the structure of the vitamin A and K. It can be done by using the ultraviolet visible spectroscopy. And next is you can differentiate the different geometric isomers of the substances. Then also you can distinguish between the conformations of different compounds. So these are some wide range of applications of the ultraviolet visible spectroscopy. Thank you.